All right, so taking a look at systems of linear equations today. So remember, your calculator will actually solve a system of linear equations for you. You can use this on multiple choice and to help you check your answer on the short answer part 2, 3, 4. But you most of the time they're going to say algebraically, which means you have to actually show your substitution and elimination work. Okay, so real quick, to actually get the solutions, we're going to go new document, open up a calculator page, and then menu, algebra, and then choice 2 is solve systems of linear equations. So we want two systems, two equations, x and y are my variables. Click OK, and then we're just going to type them in. So 2x plus 2y is equal to 16. And then 3x minus y equals 4. And then all I want to do is basically type in the other systems until we figure out which one has the same solution. Now, the other method to do this is basically to check which of these are equal to this system. So if you look at the first one, this is the same as this, and this looks like it's just multiplied by 2, right? But if I distributed, this shouldn't be 4 anymore, it should be 8. So we know this one's wrong, okay? The second system, still the same, right? And we distributed, we get 6x minus 2y equals 8, so that would be correct. And the third one, it looks like we're cutting it in half to get from the 2's down to just the x's. But this is staying 16, and this instead should be 8, so we know that's off. And in the same context, we are multiplying through on the top by 3, and in the bottom looks like it's by 2, except we have positive instead of a negative. So that tells us that that's off. And then this one does not have the same solution, so you can type them in again, or just check once again. If you look at the first option, it looks like we're taking this from 4 to negative 12. So that's a negative, we're going to be multiplied by a negative 3. And just make sure that these other things should be the same. So negative 9 and negative 30 works. 6, we're going to 12, so that's times negative 2. Make sure they're all the same coefficient, and they are. So this actually does work. Remember, we don't want them to work. And number 2, we can see that this is now 20 instead of 4. So that would have to be times 5. And then this still stays the same, so it's okay. And instead of negative 18, right, instead of negative 2 here, this would be a 3. And this does also work. So that one's out. For option 3, we want it to become 24 here. So this would be a 6. And if we distribute, we do get 24, 18, and 60. And then for negative 24, we want this to be a 6. So it should be negative 24, negative, right? Oh, sorry, not 6, 4. Negative 20, and then negative 64. So that also works. And for choice 4, the top we want it to be multiplied by 10. So 40, 30, and 100. And the bottom we want to multiply by 6. So it would be negative 6. So positive 36, negative 30, and this should be positive. Oh, there's our problem. So that's our choice. All right, if we go on to the next one, we're talking about substitution here. So with substitution, we want to take one of the equations and we want to solve it for x or y. Okay, first thing we're going to do is solve for x or y. Second thing we're going to plug in, we're going to substitute or replace. In the other equation where you see the same variable, you're going to plug in what you solve for. You're going to solve the equation that remains. There should be one variable here. And then you're going to substitute whatever solution you got into one of the equations. And make sure you write your solution as a point. It should be an ordered pair, an x, y, with parentheses. Okay? So for the first one, it's just which of these could he use? So if we took the first equation and solved it for y, we would want to move this 3x to the other side by subtracting. So I get y is equal to negative 3x minus 4. And then what I would do is, where this says y, I'm going to plug in that 3x minus 4. So it's 2x minus 3. And instead of our y, I'm going to write negative 3x minus 4, and then equals negative 21, which is the same, right? We can see that these two are plugging into the wrong spot, so that's out. And this one, the difference is one's negative, one's positive. We know our choice is number 3. In 272, we want to check to see if this really is the empty set. And if it is the empty set, what should happen is our equation should equal out to something that doesn't make any sense, like 4 equals 5, or 2 equals 6. Like the equation you get left over, the x's should drop out and it shouldn't work. It shouldn't be equal. Okay, so we already have this solved for y. So where the y is, we're going to plug in that 3x minus 2. So it's 6x minus 2, parentheses, 3x minus 2 is equal to 4. And we distribute the negative 2, we get 6x minus 6x plus 4 equals 4. And we can see that these 6x's are essentially going to cancel out here. So I get left with 4 equals 4, or somewhat like 0 equals 0 if you got everything on the same side. So this works. This works. So that means this is an infinite number of solutions. So instead of this being no solution, right, there's an infinite number of solutions. So what we would want to do here is just tell the world, John's wrong. There are an infinite number of solutions, not no solution here, okay? All right, let's go to the next page. Take a look at elimination. So in elimination, our job essentially is to take our equation they gave us, okay? We want to get rid of one of the variables by making them opposite numbers, okay? So if I wanted to get rid of the y's, okay, I want them to be the same number but have opposite signs. 4, negative 4, 3, negative 3, 100, negative 100. So it says I'm going to multiply this by negative 2, okay, so that I end up getting negative 4y and positive 4y, and therefore these will cancel out. And then I'll just solve the remaining equation. I'll take my answer and plug it into one of the equations to figure out what the y variable is, and I'll state my solution as a point. Now, in the 265, I want to know which of these options would actually be doable. The first option is if I take equation A, right, which is 5x plus 9y equals 12, and I multiplied this by negative 1/3. Would this allow me to cancel out the equations? So negative 5/3 x minus 3y is equal to negative 4. And the bottom equation is 4x, right, minus 3y. So notice that these are the same. That's not going to let them cancel out. It's going to give me negative 6. So that option doesn't work. So we're going to undo that work. Okay? All right, so if we take the option 2 here, which is to take the equation b, right, and multiply it by 3. So 4x minus, well, that's an x, 3y is equal to 8, and I multiply it by 3, I'm going to get 12x minus 9y is equal to 24. And you can see in equation A, it's 5x plus 9y. So these will indeed cancel out, okay? So this works. That's my choice. And the second one, if we multiply equation A by 2, right, and the other one by negative 6, this is going to turn into positive 18, and this is going to turn into positive 18. So once again, they're not opposites, okay? So it doesn't work. And at number 4, if I multiply equation A by 4 and B by 5, I'm going to get the same sign instead of different signs. So that's another reason why this doesn't work. Okay? All right, on the next one, careful reading. Okay? So first of all, let's move this over here. Not that far. This guy, get over there. All right, so before we get into 281, let's look at word problems. So this, by the way, is the same question as the last one. So I'm just going to stay on this page right here for our purposes. Okay? So when I look at word problems, the first thing I want to do, remember, to get in the door, we need a key. So we're going to make a key. We're going to define two variables. Usually at the end of the question, it'll say what to solve for, or here it says write the system of equations that can be used. And it says the price of one popcorn and the price of one drink, and then determine. So here I have to come up with a system of equations first, and then I have to actually solve it. Same thing. Write and solve the system's equations to determine the price of one plain pizza. So this question is going to help us get the key. Then we make our equations by reading the problem. Okay, so we want to make our two equations. And you can see like the total is 1825, and it's 2 bags of popcorn and 3 drinks. Okay, on the next line, you can see it's 2750 for 4 bags of popcorn and 2 drinks. So I'll be able to make an equations, and then I'll solve either substitution or elimination. Make sure you plug back in, and then we'll just state our equation by plugging back into our key. Okay, so we're going to start by saying x is equal to, all right, so we'll say x all right, is equal to the cost of 1 bag of popcorn And then the same thing, y. You want to get specific, so don't just say popcorn, okay? Cost of a drink. Make sure it's 1 bag of popcorn, okay? And so now we're going to make our equations. So we know for the first one, okay, it was $18.25. And that was equal to 2 bags of popcorn, so 2x plus 3 drinks is 3y. And the other one was $27.50. And that was 4 bags of popcorn and 2 drinks. And so for this system, it's kind of easiest to use elimination because I don't have an x or a y just by itself, okay? You could use elimination, but for this one, I think addition's easiest. So remember, what we're going to do is we're going to multiply one or both equations by a number. We want opposite coefficients. So for example, on this one, if I wanted to cancel out the x's, I could multiply this by -2. So these will both turn into -4s and then cancel, okay? Or I could get rid of the y's. And I need the 3 and the 2 to be the same number of opposites. So they could both become 6. And I would multiply this by 2 and 3. But if I did that, I would get 6y and 6y. So I need to make one of those two equations negative. I think it's easiest to kind of look at it in terms of the x's. I just only have to change one equation. So we're going to multiply this by -2. And then we're going to get our answer here. So we're going to get, this is 36.5, 36.50. Just going back and finding this. So 1825 times 2, we talked about this already, okay, is 37, no, that's 75. Is 36.50, okay, and that's equal to -4x plus, actually minus 6y. And this one's just going to stay the same. So 27.50, and this is equal to 4x plus 2y, and then we'll just add. So 27.50 and 36.50, okay, we can just subtract those amounts. We're going to get 9, and then these are going to cancel, and we're going to get left with 4y, and then we'll just divide by 4. And it does say the nearest cent, so we know we need to just round to, and this is $2.25. That's what y is. And now I need to go find x. So I'm just going to pick one of the two equations. We'll pick the bottom one because it's a little easier for me to plug into, by the way. That should be y, okay? So 27.50 equals 4x plus 2 times, we got 2.25. And so we're going to get 27.50, and that's 4x plus, and this is essentially 250, 225 and 225 is 450. We'll subtract the 4.50 from both sides. All right, and we should end up with 23. All right, that's equal to 4x. We'll divide both sides by 4. And then we have our answer, which is $5.75. And so we want to just state our final solution here, okay? So state the price of a bag of popcorn and the price of a drink to the nearest cent. And so a bag of popcorn costs $5, and a drink $2.25. And there's our first one. All right. Second equation, 2 friends went to a restaurant, decided to order a plain pizza and 2 sodas. So plain pizza, 2 sodas, there's the cost. Later, 5 friends went to the same restaurant. They ordered 3 plain pizzas, and each person had a soda. That's 5 sodas, people. The total is $45.90. And we want to solve. So same thing, we're going to come up with the cost of a plain pizza and the other one was soda. So even if you want to use other variables, so let's just say P, right, is equal to the cost of a plain pizza, and we'll say S is equal to the cost of a soda, or a dode, whatever that is. All right. So same concept here. First thing we're going to do is, after we get our keys, make our equations. So we know that one pizza, a P, plus 2 sodas was equal to $15.95. And the other equation we had was that 3 pizzas plus 5, because it's 5 people, 5 sodas, was equal to $49.50 or 90. Whoa, $45.90. Let's try that again, people. All right. So we're doing this question. There. So we're doing this question. I think it might be easiest to use substitution here, but if you want to use elimination, go for it. Okay, so we're going to do substitution because we just did elimination anyways. So I'm going to solve for P because that's by itself. So I'm going to subtract 2s from both sides. Okay, and I get left with P is equal to 15.95 minus 2s. And then I'm going to plug this in for P in the other equation. Okay, so we're going to get 3 parentheses 15.95, all right, minus 2s plus 5s. And you know what? I'm just going to move that down. I need some more room here, guys. I'm going to rewrite it down below. Me writing small is making that really not fun to read. Okay, so we're going to do 3p plus, and instead of p, remember, we're plugging in. So 3 parentheses 15.95 minus 2s, and then plus 5s equals 45.9. So I distribute the 3 through first. So 15.95 times 3, grab the old calculator here, is 47.85. And then minus 6s plus 5s now is equal to 45.90. So I'm going to subtract the 47.85 from both sides, and I'm going to also combine like terms here, okay? And then we're going to get negative s is equal to, and then 45.90 minus that last answer we just got is negative 195. And since they're both negative, that means our divided by -1, and we got a little can of soda is equal to $1.95. Okay, now we want to do the pizza. So we just got to take our equation, which is the first one's pretty easy. It's P plus 2s is equal to 15.95, and we're going to plug in. So this s is 195, so P plus 2 times 195. 195, little city honors. Can't even get away from the hilltop on the homework. Is equal to 15.95, and then we just double. So 1.95 times 2, we get P plus 390 is equal to 15.95. Subtract the 390 from both sides, and we got ourselves a pizza. And that's $12 and then 5 cents. And so make sure you state that as a little statement for ourselves. Cost of pizza, right, is $12.05, and then we're good to go. All right. Last page is by graphing. So remember, we're going to graph our systems of equations. We just want to know where they cross. So we're going to solve both equations. Remember, we want the slope, we want the y-intercept. Begin with the y-intercept, move with the slope. Special cases where there's no solution, the lines are parallel, they're not going to cross. And if the lines are the exact same line, coincident, which means they land on top of each other, there's infinitely many solutions. So if the line goes right on top of the other one, it becomes the same line. All right. Local business was looking to hire a landscaper to work on their property. You guys can read this here. So $12.50 per hour flat rate. The other one is $70 per hour plus a $1,600 fee. Various systems equations determine the number of hours must be worked for the company to be the same, and the grid below. It is estimated to take at least 35 hours to complete the job. Which company will be less expensive, and then justify your answer. So the first company, let's say we do the flourishing. Flourishing. All right. Y is going to be your cost, and then that's equal to, and this is a flat rate, so it's 120 times hours, so it's just 120x. All right. And then the green thumb is Y, the cost is equal to $70 per hour plus $1,600 fee. So that's it. So we know our slope here is 120 over 1, and our y-intercept is 0. For the other one, we know our slope is 70 over 1, and our y-intercept is 1,600. All right, so if it's estimated to take at least 35 hours, we kind of want to know where these lines are going to cross. So we're going to want to make a pretty big number. So if you have your calculator, okay, we can type this in here. And this is a good question for this because we have our normal calculator window is pretty small. So we're going to go graph. We're going to do y is equal to 120x. Okay, you can see it's like crazy. It's super small right here because at 1, it's at 120. So it almost looks like it matches the x-axis. It almost looks like it is the x-axis. It's just a little bit off. And then tab, and we're going to do 70x plus 1,600. And this one we can't even see. So what we want to do is we want to zoom out here. And so we go to Windows Zoom, and if we do it fit, you can see it kind of makes our stuff bigger here. And oh, look at that, we can kind of see our lines. I might actually want to zoom out here. It's going from an x of 10 to negative 10. And so if I zoom, I can just zoom out, and I can just click at the center, and I can just make these bigger. And then there we go. So now I can see where these are going to intersect. So let's find that point first. We're going to go to Menu, Analyze Graph, Intersection, and we're going to zoom in on the intersection point. And look at this, 3.84 e plus 3. What is that? What's this e thing? Remember, you guys learned this last year, this scientific notation. So what this actually means is it's 3.84 times 10 to the third power. Okay, so 3.84 times 10 to the third power just means that I'm doing 3.84 and then I'm moving the decimal point, okay, 1, 2, 3 spots. So it's essentially 3,840. That's what we're looking at here. So we need to get pretty big here, okay? We also want to know what's the cost after 35 hours, right? So if we do Control T, we can actually scan down to 35 and figure out we need to go all the way up to the 4,200 here. So we need to get this pretty big. So how about if we have some room here, okay? I'm going to delete this out of here though. So I'm going to get rid of this stuff on the bottom because I need some room here. So on my graph, all right. And now I want to get up to 35. So we'll count by, let's say, 2s. We're going to do 0, and we're going to skip. So 4, 8, 6, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, and then 38. All right, and then we're going to count, and we want to get all the way up to about 4,000. So if I count by hundreds, 1, 2, 3, 4, 5, 6, 7, 8, I'm not going to have enough. If I count by 200s, so there's 400, 600, 800, that'll be 1,200, 14, 1,600, 2000, and am I going to have, I'm not even going to have enough room to do this because I got to go up to about 42. Well, we'll keep going. So that's 2000, this is 22, this is 24, 28, 32, 36, and then 4. Now we know the intersection point is a little bit lower, so we'll be able to graph this. So the first one is y equals 120x. Okay, it's kind of hard to graph 120x. I have to go up 120. So what I might want to do is go back to my table and just pick out some nicer points. So the first point we have is 0 and 120. The next point we have is 5 and then 600. So I'll go over to 5, which is in between 4, right, and 6, 5, and then 600. So I got 1 point there at 0, 0. I got 5 and 600. There's another point. Okay, the next nice point we're going to get is at 1200, and that's at 10. So 10, 1200. All right. And see, I'm using the points on my table to graph instead of the slope because it's a little hard to do 120. And then I'm going to draw my line in here for myself. So starting at 0, straight edge, ruler, compass, not compass, bus pass, whatever you got here. And there's my line. And remember, it has to intersect, and it's going to intersect, so I want to make sure this extends all the way up the graph here. Way up there, get up there. All right, now it's not going to go below 0 because I'm not going to have any negatives. So I only really need this, this one arrowhead here, okay? All right, and then we want to make sure we put the equation on the graph. So we'll do y equals 120x. All right, the second one. Same thing here. Now this one has a y-intercept of 1600. So at 1600, I'm going to go ahead and put a dot. And then we are going up essentially 70. So same thing. I can use the table here to kind of go try to find a nice point along the way. And we get one at 2300, right? And at 3000. So 20 is 3000. 20, I'm going all the way up to 3000. I'm going to put a dot right there. And then I'm going to go ahead and draw a line through those 2 points. Bam. Bam. I'll just use a different color there. Okay. So we're going to go blue. So from here through there. And there we go. All right. And once again, arrowhead. And I got y is equal to 70x plus 1600. And I want to make sure I label where they intersect. So I know the intersection point, and I can also, so we know it's 3084, essentially 100. But if I really wanted to get the answer, I should really plug 32 in. So if I take my first equation, it's 120 times 32. This is going to give me the exact answer, 3,840. That's why it's times 10 to the negative 3, okay? So we're going to put that dot on there for the intersection point. We're going to label it. So this is 32, comma, 3,000. We said 840. All right. So we can answer the question here. And we can also figure out that at 35, right, if you travel up the line here, so, and we'll do a little pink line for you guys here, because why not? So we can see 35 is essentially the middle here, and if we draw a line straight up, we can see which line is going to intersect first, right? And it's going to hit this line right here. We can also plug in, so we can actually check the table, right, at 35. And we can see like that's less than this is. So it's actually cheaper, right, to do this guy, the 70x plus 60. So if it says estimated take which job and then justify your answer, you could either point it out on the graph that this is lower, you can substitute in the equation, it's totally up to you. But it does say the number of hours worked, that they'll be the same. We label in a graph, so we would say it will take 32 hours for the cost of each company be the same, and it will cost, let's say if it takes 35 hours to complete the job, then what's the GT company again? The Green Thumb Landscaping Company is last. Well, because let's see, they're like the graph, the y value is lower at that point, okay? Or you can say when you plugged in, the answer came out correct. It does say justify, so as long as we say which is which, we're good to go. So we're indicating that out. You can explain it in words, okay? The y value equation is less at that point. And there's your explanation. All right, that's it for tonight, guys. Have a great night, and I'll see you guys tomorrow.